Hi everyone, welcome to Job Fever. So today we are going to learn most important topic of data structure, which is linked list. So we are going to cover all the types of linked list, which is single linked list. It is also called single linked list, doubly linked list, which is also called double linked list, and circular linked list. We are going to cover all the types of linked list. So we are going to cover from basic to advanced in this entire video series. So it might take around 4 hours to understand each and every point, so please be calm and try to understand each and every point. So I have designed this course only for beginners, so I will cover from basic to advanced. So firstly we'll cover our theoretical part, and then we'll do the coding related things. So you're an advanced person, so directly you can go and you can watch the coding related things. So in this tutorial I'm going to cover internals of linked list, how internally it works, and coding related things. So how can we add at first position, how can we add at last position, how can we delete from last position, and how can you delete from first position, and traversal from forward traversal, backward traversal. Okay, how can we display element which is available inside linked list, and coding related things concept we are going to see in this entire video tutorial. So please try to understand each and every point. So let's learn together. Let's get started. confused. So we are going to continue our double linked list. Okay, so in this tutorial we'll cover what is double linked list, internals of double linked list, add element at first position in double linked list, add element at last position in double linked list, delete element at first position in double linked list, and delete element at last position in double linked list, in coding questions of double linked list. So we'll try to do parallel coding. Okay, we'll firstly try to analyze how can we do, and then we'll do the parallel coding for all method of double linked list. So this tutorial is for beginners only. If you want to, if you are advanced person, so directly you can go to the coding person and you can see the approach. So we'll start from basic only. So let's get started. So firstly, we are going to understand what is doubly linked list. So doubly linked list is a type of linked list. So in previous video, we've seen there are three types of linked list. First will be single linked list, second double linked list, and fourth will be circular linked list. So we have covered the single linked list. So now we are going to cover double linked list. So a doubly linked list is a data structure that consists of set of nodes. Okay, each contains a value and two pointers. So in single linked list, single linked list it contains one value and one pointer. So now in double linked list it's contain one value and two pointers, one pointers to the previous node. Okay, and in the list, and one pointers to the next node in the list. So two pointer, that means the two pointers, one pointers to the previous node in the list and one pointing to the next node in the list. Okay, this allows for efficient traversal of the list in both directions, making it suitable for applications where frequent insertion and deletion are required. Okay. So frequent insertion and deletion are required. So in this scenario, you can use linked list, doubly linked list. So in Java collections, linked list is there. So linked list internally use doubly linked list concept. Okay. So now we are going to understand all the internal concepts how doubly linked list internally works in next slide. So doubly linked list. Okay, previous node. Okay, this is one node of your doubly linked list. So this is the previous node, and it will store the address of previous node, and here it will store the address of next node. Okay, and this is our data, this is our data which is 100, and this is address of your previous node. Okay, and this is address of your next node, okay, let's imagine if you have node, node, okay, left node, right node. So this will be the address of previous node. Okay, and this will be address of your next node, and this is the data of your node. Okay, so like this we can store node wise data inside linked list, doubly linked list. So see this, now we are going to store data inside doubly linked list. So we want to store 10. Okay, so what will happen if you will store 10? So this is our first element. So first element of uh, your linked list. So here we are getting null, that means there is no previous node. Okay, previous node is not available for this node, and when we are getting xx20, that means this is the next node, address of next node, that means we'll get the address of next node. Okay, so we'll get the address of this is address of xx10, address of this node, this is address of your previous node, this is address of your next node, and this is data which is 10, which we want to store inside doubly linked list, and this is address of your current node. Okay, see this is our second node. Okay, in second node you want to store 20. Okay, if you want to store 20, So in second node, what it is happening here, so it is storing the address of previous node, okay, which is xx10. So this is address of previous node xx10, and xx30 will be address of your next node, okay. So in next scenario, the address will be the next address of next node will be xx30, okay. So and the address of current node is xx20, xx20, okay. If you'll see the first node, so first node next uh, next is pointing to address of your second node, which is xx20. So same like if you want to store 30, so in this scenario also, this is the address of previous node, which is xx20, okay, and xx40 is address of your next node, and xx30 is your address of your current node. Again 40 if you want to store, so xx30 is the address of your previous node, and xx50 will be address of your next node, okay. Xx30 is the address of your, and at last this is your last node. So how can you understand this is my last node? Because there is no node after this, okay. So here we store address of your next node, so we are getting null. That means there is no node present after this node, okay. And this is address of your previous node, which is xx40, and this is address of your current node xx50. So if you'll see the arrow this, so xx20 is pointing to address of your next node, okay. Xx10 is pointing to address of your previous node, xx30 is pointing to address of your next node, and xx20 is pointing to address of your previous node, xx40 is pointing to address of your next node, and xx30 is pointing to your address of your previous node, and again xx50 is pointing to address of your next node, and again xx40 is pointing to previous address of your previous node, okay. So like this all the node will be chained together, okay. And after that you will get one head, okay. So head will be also a node type, okay. So head will point to address of your first node, okay. So this is our first node xx10, okay. So head will point to your address of your first node, which is xx10. This is address of your first node. So by this head you can understand that means the this is my starting node, because in head what we are assigning the address of your first node, and we'll also get one tail, okay. So in tail what will store the address of your last node, so our last node is xx50. So here we are storing address of our last node, okay. So like this we represent, okay, a doubly linked list or double linked list, okay. And this is internals of doubly linked list. So here we are storing the head, and here we are storing the tail. So we'll try to understand all the concept, how can we add, how can we delete everything, okay, and how can we transverse, okay, from forward backward everything with the help of this head and tail, okay. So let's move to next. So add elements at first position. So how can we add elements at first position in your doubly linked list, okay. So if linked list is empty, okay, so add element at first position, we want to add element at first position, so there might be possibility that linked list is empty. That means that there is no node available in doubly linked list. So in this scenario we can identify there is no node available in linked list. If head is equal to null, if head is equal to null and tail is equal to null, okay, that means head is not pointing to any element and tail is not pointing to any element, okay. Head is not pointing to any node, and tail is also not pointing to any node. That means the our linked list is completely empty. In this scenario you want to store first element at first position, okay. So how can we do, okay. So for that purpose we have to create one node firstly, okay. So if we create the node, then we'll get the node and address of that node, okay. So this is our new node. We have created one new node we have created, and the and this is the value of new node, which is 50. We want to store 50 inside new node. Okay, so by default the value of new node will be null. Okay, and this will be also null. So by default the value of your new node will be the value of your previous, so both will be null. Okay, so this will be the null and this will be also null. So we have created one new node, so data will be 50. Okay, and the address of your previous node will be null and address of your next node will be null, and we have address which is xx50. So we want to create this node as a first node of your linked list. Okay, because there is no node there is no node is available inside your linked list, so this will become your first node of your node. So how can we do? We have address of your node. Okay, so how can we do? Replace value of head by address of new node. Address of new node. So what is address of new node? Xx50. Okay, so what we are going to do? So we are going to address replace value of head, this one, by address of new node. So our address of new node will be xx50. So we replace null by xx50. So we have deleted our we are going to replace null by xx50. So now we have xx50 inside head. Okay, and now xx50 will point to your new node. Okay, so now head is pointing to new node, and what will be the next step? So replace value of tail by address of new node. Because in doubly linked list, what we are keeping, uh, record of your head and tail also. So we have assigned our new node value inside head, but we have to also assign our new node value inside tail. Okay, so now we have to replace value of tail. Okay, replace value of tail, which is null here. Okay, by address of new node xx50. So we are going to replace tail value by address of new node, which is xx50. So now xx50 tail will also point to new node. Okay, so we have created one node, and we have address of that node, and we have replaced the address of this node. Okay, we replace the address of head by address of new node, and we replace the address of tail by address of new node. Okay, xx50. And now head and tail both are pointing to new node. Okay, that means we have only one element inside linked list. Okay, so like this we can store first element at first position if linked list is empty. So let's start coding, parallel coding. We'll try to store we try to store node at first position. Okay, so this is the first scenario, and second scenario I will also try to make you understand. So how can we add element at first position if linked list is not empty? We see in this condition if linked list is empty. So I will also try to make you understand this one, add element at first position. Okay, when if linked list is not empty. Previously, you've seen if linked list is empty. If linked list is not empty, so in this scenario, linked list will not be empty. If head is pointing to x620, that means there is some element. Okay, in your linked list, there is some node in your linked list because head is pointing to x620. Okay, and tail is also pointing to x650. That means we have some element. Okay, okay, head is pointing to different element and tail is pointing to different element. That means we have more than one element inside linked list, because if both head and tail will point to to same address, that means that there is only one element, okay, inside your linked list. But here head is pointing to xx20 and tail is pointing to xx50. That means that they, uh, there is more than one node inside your linked list. Okay, so this is the structure of your node. So we have four node inside linked list. So head is pointing to x620, so this is our first node. Okay, then second, then third and fourth, and tail is pointing to x615, that means this is the last node. Okay, here we are getting previous, next we are getting null, that means that this is a last node. Okay, and tail is pointing to address of your last node, okay, which is x615, and head is pointing to address of your first node, which is x620. And now we want to add element at first position. So if linked list is not empty, we are going to add element at first position. That means that our node will be inserted here. Okay, our new node will be inserted here. So create new node. So firstly we have to create the new node. Okay, so after creating new node, we will get the we are getting new node with the data 10. Okay, so this 10 will be stored at the data position inside your node. Okay, and by default the value of previous, okay, previous node will be null, and next node will be also null. So we are getting here null, and we are getting here both the place we are getting null. Okay, this is x10 is the address of your new node. Okay, so we have created one node, and now we are going to link our new node to at first position. Okay, so how can we do? So replace next address of new node, replace next address of new node by head value, so now head is pointing to x620, that means that this is our new node. This is our first node, but now if we are going to add our node at first position, so it should be our first node. So for that purpose we have to replace this address, this value of head to your new node value. Okay, so new node value is address of new node is x620, so instead of x620 it should be x610, then head will point to xx10. So replace and but in before that, what we have to do, replace next address of new node by head value. So next, replace next address of new node. So this is our new node, so next address, which is this is the next. Okay, so we have to replace by head value. So what is head value? So head value is x620, which is address of your first node. So in instead of null it should be x620, that means it should find the next element. So this is this will be the first element, so it should find the address of next element. So what will be the next element? x620. Okay, and this x620, where it is available? It is available at inside head. Okay, so now we'll make null, we replace null by address of next node, which is x620. Okay, so see, we are going to replace this null by x620. Okay, which is address of next node, and now this will find to address of your next node. So we have done our first step. Second step, okay, we have created one node, and then we have replaced next address of new node, next address of this is new node of next address of new node by head value, which is x620. Inside, what is available inside head? Address of your first node. Okay, so now we are going to replace previous address of head by address of new node. Replace previous address of head. Okay, that means here also we have to change the value. Okay, so here previous of, so previous of this, what should be previous of this node? Because this will be our first node, so the previous of this node will be, see, address of new node, which is xx10. Okay, so xx10 we have to replace here. Okay, so in third steps it is saying replace previous address of head, replace previous address of head, that means the head is x620. So x620, this is x620, and a previous address of head, so this is the this will be our previous address. Okay, null by address of new node, address of new node will be x610. So instead of null we have to give x610. So going to replace null value by x610, and now this x610 will point to address of your previous node. Okay, so now we have done, 3 steps. And what we have to do now, replace head by address of new node. Okay, so still head is pointing to your old value. Okay, that means the second second node. Okay, so now this will act as a first node. So now we are, what we have to do, replace head by address of new node. So we have to replace this head by address of new node, which is xx10. So now we are going to replace xx20 by xx10. Okay, so now this head will point to, so now this is not pointing to your previous old one. Okay, so now head is pointing to our new node, which is xx10. Now this is the this is so like this we have like this we can add first uh, node at first position. Okay, so now we have added, so now this is our first node, and this is the next, then this is the next node, this is the next, and this is the last node, and last, and tail is pointing to our last node. Okay, so like this we can add element at first position. So now we are going to start coding. Okay, so how can we do with the help of code? Okay, so doubly linked list. Now, so let's remove all the codes. We'll do again everything from starting. Okay, doubly linked list, and I've done the POC, but again we'll do from scratch. Okay, so doubly linked list, we are going to do, we have created one class with doubly linked list. This is the main class. So now we are going to create one node class. So class node, private class and node. So what will be inside node? We have data, int data. Okay, so private int data, and private, what will be inside node, value address of previous node, and private address of your next node. Okay, so it should available inside node. So what will be the prep type will be also a node. Okay, because in previous it is also going to store a reference variable of your previous node. Okay, so the type of previous will be also a one node. Okay, and the what will be the type of your next node will be also node type, because same here we are also going to store a reference of your next we are going to store a reference of your next node inside this next, so it should be also a node type. So now we have created three things: data, previous, and next inside node. Okay, so now we are going to create one constructor. When we try to create one node, so what will happen? So public node, what should happen? So here we are going to provide int data. So at the time of creating node, we have to provide the data, this dot data equal to data. We are going to assign data by this dot data is equal to data. And now remaining thing, which is previous. Okay, this dot previous equal to null. Okay, by default, if you are getting the new node, so our previous will be by default null, and then this dot next should be also null. Okay, so if you get the new node with the help of the constructor, then it should be like this. Okay, it should be assigning one value inside data, and previous node should be null, and next will be also null. Okay, so we have created one node. Okay, so each node should be available inside doubly linked list. Okay, in and and inside doubly linked list we are keeping take record of two things, which is and head and tail. So we are going to create variables for head, hed head, and private tail. Okay, but we have to assign here type of head. Okay, because we are getting compile time. So what will be type of head? Okay, so in type, what we are storing inside type, we are storing in reference of your first node. Okay, so reference of your first nodes. So for storing this, for storing the reference of any node, so head should be also a node type. Okay, otherwise you will not, you will get the compile time error. Okay, so tail also, in tail also we are storing the address of your last node. Okay, so tail is last node is also a node type. So here in tail we are storing the node, so it should be also a node type. So now we are storing in double link. What we are doing here, we are storing the address of your first node inside head, and we are storing address of your last node inside tail, and then we have all the node will be available here inside node, data will be available, or inside node address of your previous node will be available, and address of your next node will be available. Okay, so it will be like node within node, you can say it will create like a chain. So we have done these things, and we want to track size of this link, doubly linked list. So how can we do? So I'm going to create one size variable. Okay, so we'll keep tracking size of our linked list. So it's done now. So now we are going to create methods to add first node inside this doubly linked list. So we are going to create a doubly linked list scenario in with that of the Java code. So public void add first. So we are going to add first element inside, add first inside linked list. Okay, so at first we are going to int data. So we'll get the data, and then we have to, so we have two condition in add first. First condition will be if linked list is empty, and second if linked list is not empty. That means that there is some there is some node available in linked list. Okay, linked list add first, we are going to add first element inside linked list, but there is no node inside linked list. So this your new node will be acted as the first node of the linked list. So in this scenario, how can we do? Just now we seen in ppt, that means how can we do? So if linked list is empty, so in which condition our linked list will be empty? Okay, if head equal to null, that means the head is not pointing to anything. In this scenario, linked list is empty. So how can we do? So firstly we have to create one new node. Okay, new node. So I'm going to create on the top node, new node equal to new node is equal to new node. Okay, so we have created no new node with that of the constructor, and we are going to provide 10. So we have created, but we have created new node. So what we can do, head, inside head we have to assign the value of new node, which is head is equal to new node. Okay, so and we have tail also. So inside tail, because tail is also pointing to null. Okay, so tail we have to also provide the address of new node. Okay, so now we have one node inside linked list, and the address of new node is pointing to the head is pointing to address of new node, and tail is also pointing to address of new node. So we have done, and we are I'm going to return. Okay, if everything is done, so and now we are going to write condition for second scenario if linked list is not empty, and if your data will be added here. Okay, if your node will be added inside the linked list, so size we have to also increase. Okay, because we are also going to track record of size. So our size will be size plus plus. So now we are going to write logic when linked list is not empty. So in this scenario, what we can do? So we have created one node. Okay, linked list is not empty. That means how can we analyze if linked list is not empty? That means the our head is our head is not equal to null. That means head is pointing to something. So in this scenario, linked list is not empty. And now we are going to add first element before available element. So how can we do? So just now we see in previous. So firstly, we have created one node here, and now we are going to do what we are going to do. We have new node. So in new node dot next, we'll in new node dot next we will provide the address of your next node. So address of from where we will get the address of your next node in head. Head is pointing to address of your address of your next node. Okay, so now we'll do here new node dot next is equal to head, and then we have in new node dot next we have done head, and what we have to do, so this will act as a so in previous no need to do anything because new node dot new node dot previous is already pointing to your null. Okay, so if you are going to make your new node as a first, so this is not required because by default the new node previous will point to null. Okay, so this is not required. So second thing what we have to do, so we have to change the address of your head. Okay, because now head will be your new node, so head equal to new node, and next thing you have to tell. Okay, so so tail will there is no need to change anything in tail because tail will still point to your old node. Okay, so new node that next equal to head we do, and head dot previous is equal to, and now we can do size plus plus. Okay, so this is not required new node dot previous equal to null because by default the new node dot previous will be null, and this new node will act as a first first element of your node. So what we did in new node dot next, okay, in new node dot next we have provided the head value. So we'll try to see the, yeah, this one. We have created one node and then replace next address of new node by head value. Okay, and then we have replaced previous address of your head by address of your new node. Okay, so that means we have to do one thing, which is, so we have changed the address of your next address of your new node is equal to head, but we have to again do, we have to change the previous address of your head. Previous address of your head is pointing to your current node. Okay, so we have to change there also. Okay, so for that purpose we have to do head is pointing to your second, so head dot previous equal to new node. Okay, so head dot previous will be new node, and new node dot next equal to head, and again we'll check anything is remaining, and replace head by address of new node. So we have done this, replace address replace head of address by of, sorry, replace head by address of new node, replace head by address of new node. Okay, so we have done this linked list if linked list is not empty, so, and if linked list is empty, so both the scenario we have covered. Now we are going to create new method, okay, which is for to add the element at last, okay, last position, at last position. So for that we'll create one method, public void add last int data, okay, data. So in the seed of 10 we have hard coded, we will make here data, okay. Now we are going to add last position. So same for last position also we have two condition. If linked list is empty, empty, and if linked list is not empty, both the scenario we have to cover. So if linked list is empty, add last. If linked list is empty, so at last that means the if you try to add at last, that means you are going to add first element inside your linked list because there is no element inside linked list, okay. So for that purpose, this code will be same, linked list is empty, okay. So this code will be common for both the scenario because we are going to add new element inside your linked list, okay. And if linked list is not empty, so how can we add your element at last position? So for that purpose, firstly we'll try to analyze how can we do with the ppt, and then we'll do the code, okay. So next slide we'll see add element at last position. So we are going to see in this scenario if linked list is not empty. So if linked list is not empty, that means head is equal to xx10 and tail is equal to xx40. That means head is also pointing to something and tail is also pointing to something. That means the linked list is not empty. But in linked list we have multiple value because head is pointing to different address and tail is also pointing to different value. So in linked list we have multiple value, okay, more than one value, okay. So see, so this is our first node which is xx10 and this is our last node which is xx40, okay. So there is no, and we are going to add the element at last position. That means our element should be added here, okay. So how can we do? So firstly we have to create one node, and the node address of your node will be xx50 new node address, and then inside previous it is pointing to null, and inside next it is pointing to null because they, okay. And now we are going to sync inside sync with linked list nodes, okay. So next step, what will be our next step? So replace previous address of new node by tail value. So tail is pointing to last, okay, which is xx40. So we are going to replace previous address of new node which is null now, okay, of new node of tail value. New node, replace previous address of new node, this is by tail value. That means the what will be the previous? So now previous should be xx40. So instead of null we are going to replace by xx40, okay. So and tail is containing xx40 value of your last node, okay. So now null will be the replaced, and instead of null what will be available? xx40, okay. And what will be the our? So we have done this. So now what will be the next step? So now this previous is pointing to new node of previous is pointing to your previous node, okay. And now we are going to do replace next address of your tail node by address of your new node. So you replace next address of your tail node. So tail node, this is xx pointing to xx40. So xx40 replace next address. So next address is here xx xx30, okay. Basically it should be xx40 because this is our xx50. So sorry, no, right, this is previous, okay, right. So replace next address of your tail node. Okay, so this is previous, this is next. Okay, so this one we have to replace, this is null. So what should we have to provide what we have to provide here? By address of new node. So what address of new node is xx50. So industry of null here should be xx50. So null we are going to delete and xx50 we are going to assign. Okay, now the uh, now next will point to address of your new node xx50. And what will be your third step? Replace tail value by address of your new node. So tail is still pointing to your previous node. So now tail should point to your last node because this is our last node. So in the series of xx40 it should be xx50. So xx50. So in next step we'll delete this xx40. Okay, and we'll replace by new, which is xx50. So now this tail will point to, now tail will not point to your previous node, it will point to your new node. So tail is pointing to your new node. Now our operation is done. So now head is pointing to xx10, which is your first node, and now tail is pointing to xx50, which is last node. Okay, and we have replaced, okay, this next by address of a new node, and previous of new node we have replaced by this previous node. Okay, so like this we can add element at last position. So let's continue the coding. Okay, if linked list is not empty, so in this scenario how can we understood if linked list is not empty? The same scenario. Okay, if there is something inside a head, so head not equal to null, that means linked list is not empty, and we are going to add at last position inside your linked list. So our new node, okay, new node dot previous should be your tail, and your tail dot next should be new node. Okay, and then we have to change the value of tail equal to new node. Am I right? New node dot previous is equal to head, new node dot previous, new node dot previous is equal to tail, and tail dot next is equal to new node, and tail equal to new node, and yeah, and size plus plus. So we are keeping take record of size also. Yeah, so it's done if linked list is not empty. So this is the code. I think it should work. Now we have done the code for this also. So second and third we are going to write method to print. Okay, print display the value of linked list. So display. So we have two way to display, which will be from forward transversal, and second will be backward traversal. Okay, so we are going to do by forward now, then we'll do by backward. So display by forward traversal. So public void and print forward. So system dot out dot println print forward. So if linked list is empty, you want to print and linked list is empty, so this is one condition. So in this scenario, it should not print anything. So it should, in this if linked list is empty, that means head equal to null. Okay, nothing is there inside linked list. So we have to print simply print forward, print forward. Okay, so we have to print, that means the linked list is empty. Linked list is DLL double linked list is empty. Okay, now linked list is not empty. Okay, linked list is not empty. That means more than one. So how can we do if linked list is not empty? So if you want to print, then firstly we'll try what we are going to do here. We are going to assign, firstly we print the current value of your current node. Okay, first node. So we are going to create node, current node, current node, this, and head. So we are going to assign head inside current node. Okay, so this is our, we have fetched the current node. This will be our current node. Okay, so firstly we are going to print current node, and then we'll do current node equal to current node dot next. Okay, like this we are going to forward traversal. Okay, so while will our loop will continue till current node, not current node dot next, or current node not equal to null. Okay, current node not equal to null. So in each scenario current node equal to null. Okay, so if you are at last node, okay, and in last node you have assigned the value of your last node dot next. So in this scenario your current node will be null. Okay, so this loop will continue till current node not equal to null. So we are going to print here value of current node. So value of current node, how can we print? So we have current node dot data. So now we print the value of current node. Okay, and then we are assigning current node dot next equal to current node equal to current node dot next. Okay, so current node dot next, current node equal to current node dot next. So now like this we can print all the value all value of your nodes which is inside linked list. Okay, so like this we can print. So let's write the logic to display by backward transversal. Okay, so let's do, so I'm going to copy and will paste. Okay, yeah, we'll modify display by backward, backward traversal. So print backward. Both the way we can do it with the help of doubly linked list. Okay, because in doubly linked list one node is pointing to previous also and next also, so it's so easy to print in backward transversal. Okay, so print in backward. And now if ll is empty, so this will be the same condition. Okay, this head is equal to null, that means so it will be same. And if ll is not empty, so now node we are going to assign current node. So our current node will be tail. Okay, because we are going to print from back to tail to head. Okay, so our current node will be pointing to tail, but that means last node of your doubly linked list. Okay, and then current node not equal to null, sys out current node dot data, and then in current node will do current node dot previous year. Okay, so every time your current node will be current node dot previous, and it will be continue till current node not equal to null. So am I right? Let's double verify. Current node equal to current node dot previous. Okay, yeah, right. So like this we can print the all the node data in backward traversal. Okay, so let's print and check are we doing right or not till now. If not, then we'll try to. So we're going to create object for this doubly linked list. Okay, so dll equal to new doubly linked list, and dll dot add first. So firstly we are going to add 10, then dll dot add last. Okay, or 20, and or add first, we'll add here add first 20, and then dll dot add last 30. Okay, and now we'll do dll dot print forward. So we are going to print. So let's run and check are we able to. So let's verify once, did we hard coded data anywhere? No, it's looking nice. So let's print. So we are getting all the output inside one line. So we'll do print ln. Print ln. Here also print ln, and print ln, print ln, print ln. Yeah, it's done. Let's run again and we'll check. Yeah, so we are getting here 20, 10 and 30. Okay, so let's verify. So we have add first 10, okay, and then 20. So before 10, 20 should be there. So 20, 10, at last 30 should be there. So 20. So firstly it will add 10. Okay, then we will get 10, and then again add first. So 20 will be at first position. So 20 and then 10, and then at third what should be there? At last we are adding 30. So 20, 10, and then 30 should be our output. So we are getting 20, 10, and 30. That means that we are getting the correct output in printing well in forward direction. So if you want to print in backward direction, so tll dot backward. Let's print and check. So our output should be 30, 10, and 20. So we are getting 30, 10, and 20. Okay, so we are getting right output. Okay, so we are able to add at first position, we are able to add at last position, and we are able to print in forward transversal traversal, and we are able to print at backward traversal. Okay, so all are working fine. So now we have covered the four methods. Now we'll try to fetch the size of current node. So how can we fetch from here? Let's write public int size. Okay, so let's return size of this. Okay, and from here return we can do size we are returning here. Okay, so let's quickly print the size of this. So dll dot size, dll dot size, and we'll do inside one sys out. Okay, so let's copy sys out from top and copy here and put this inside, this is out. Okay, and make it size. Let's print and check, are we getting current size or not. So our side should be 30, oh sorry 3. So side size we are getting 3, that means the we are able to take size also, all are right. So yeah, hope till now you understood everything. So now we will cover the delete first and delete last. So let's move to your ppt, and so now we are going to delete element. Now we are going to delete element from doubly linked list. Okay, so we have two condition. If doubly linked list has only one element, and then if doubly linked list has more than one element. So we are going to see first condition, which is if doubly linked list has only one element. So head is pointing to xx50 and tail is pointing to xx50. That means both the head and tail are pointing to only one node. So we can say doubly linked list has only one element. So this is the element. Okay, so there is no element before this and there is no element after this. Okay, so this previous address is pointing to null and this next address is also pointing to null. Okay, and both head and tails are pointing to this node only, xx50. Okay, so now we are going to delete this node. So how can we delete? So replace value of head by null. So replace value of head by null. The value of head is xx50. So if you replace by null, if you replace a value of head by null, that means you will not get anything in null. Okay, so let's remove it. So xx50 will be removed, and in the seat of xx15 null will be available in head. And now we are going to follow second step. Okay, so now there is no any pointer, there is no any link between your head and this node. Okay, so now head is pointing to null, and this will be the second step. Replace value of tail by null. So value of tail equal to xx50. Okay, which is pointing to your node. Okay, so it should be also null, because null and head should be both should be null. Okay, because there is no element in doubly linked list, because we are going to delete the which is available, we are going to delete the node which is available inside linked list. So tail should be also null. So next step, it should be deleted xx50, and it instead of xx50 it should be null. So now there is no relation between your tail value of and your node. Okay, and now so it will be deleted by your garbage collector in Java. Okay, so there is no difference between your head and your previous node and tail and your previous node. So now head equal to null and tail is equal to null. So we can say there is no element inside your linked list. So this is the one way. And second way also we are going to see. So delete element at first position if doubly linked list has multiple elements. Okay, multiple elements. So if head is pointing to xx10 and tail is pointing to xx50, so that means both are pointing to different node. So there is more than one element inside your linked list. So this is the linked list. Okay, so head is pointing to xx10 and tail is pointing to xx50. That means the last node of your linked list, doubly linked list. So we want to delete. So how can we delete element at first position? Okay, so we are going to delete element which is at first position. That means the this one we are going to delete. So how can we delete? So replace value of head by next address of head. Okay, so head is pointing to your first node. Okay, so if head will point to our second node, then there will not then so this first node will be ignored by your linked list. Okay, that means if we replace xx10 by xx20, then head will directly point to xx20. So our node will start from this, okay, from xx20 to xx50. So like this we can do. So the replace value of head, so replace value of head which is xx10 by replace value of head, this is by next address of head. So head is xx10 and next address will be xx20. Okay, so we are going to replace head by xx20. Okay, so now xx20 will be, and there is no relationship between your head and first node. Now your first node will be your second node. Okay, so second node will be act as first node. Okay, so now this will be deleted, so automatically by your garbage collector, because it is not pointing to anywhere. Okay, so now it's done. So head is pointing to xx20. This is our first element. Okay, it will treat as a first element, and head is pointing to xx50. So this will point, this is our last element of your last node of your linked list. So it's done. So let's start the coding. Okay, so how can we delete the first element from your linked list? So let's continue. Yeah, let's continue the coding part. Yeah, so this is, yeah, public void delete first. So we are going to delete from first position. Okay, delete node from, delete first node. Okay, first node from DLL W linked list. Okay, so first node, if so, if linked list is empty, okay, possibility is that linked list DLL is empty. So in this scenario you can't delete. Okay, and what will be the another condition? If DLL has only one element. Okay, one element, and second and third condition will be DLL has more than one element. Okay, so we have three cases. Okay, so in first case DLL is empty. So if DLL is empty, then it will not delete anything, simply it will return uh, DLL is empty. Okay, so if, how can we check if DLL is empty? If head equal to null, nothing is inside null, so it should return DLL is empty. Okay, it should null, it should return DLL is empty, and here should be also one return, yeah, return, and it should be, yeah, here if DLL is empty, so it should return, and it should return, so no need to go further. Okay, so if head equal to null, we have printed DLL is empty, and it will simply return. Okay, it will not go for further operation. So now DLL has only one element. So how can we, and how can we identify if DLL has only one element? That means the head is not equal to head dot next is not equal to null. Okay, so something is there inside next of head. Okay, so DLL has one element. That means DLL has minimum one element. So in this scenario, how can we do? So just now we seen in PPT. So we have to change the value of head. Okay, and our head should be head dot next. Head should be head dot next. In case of multiple, okay, but here DLL has one element. Okay, so we are going to delete. Okay, so this should not be applicable, this should be applicable for if DLL has more than one element. So DLL has one element. Okay, that means head is also pointing to head is pointing to one node and tail is also pointing to same node. Okay, so in this scenario, if you make head equal to null, if you make, that means here head is not pointing to anything. Okay, and tail, we will also do same thing for tail equal to null. Okay, so head is also not pointing to anything and tail is also not pointing to anything. Okay, that means we have completely removed the reference of your first node, available node from your head and tail. Okay, so now head will be null and tail will be null. So we have done this, and now we have third condition, which is DLL has more than one element. Okay, and you want to remove first element from the DLL. Okay, that means doubly linked list. So in this scenario, we have to delegate your head. So our head will be head dot next. So we are going to change head will be head dot next. Head equal to head dot next, and what will be the value of your previous. Okay, that means the now head is pointing to your first element because head is equal to head dot next, and your head. Okay, so head dot previous will be null. Okay, because now head will be now the address of head will become your first node. So we are going to do head dot prev is equal to null. Okay, so it will see, I will show you. So now xx10 will be null. Okay, because it will be your first node. So here also we have to change the value. Okay, that means we have to change the, now head is pointing to xx20. So we have to do head dot prev, okay, equal to null. That means it will be your first node. So like this we have to change inside our code. So DLL has more than one element, then head equal to head dot next and head dot prev equal to null. Now we have deleted the first element from our linked list, w linked list. So now we are going to delete last node from our linked list. So let's write one method, then we'll try to think approach how can we do delete last from the linked list. Delete last node, delete last element. So some condition will be same like DLL is, if DLL is empty. Okay, so in this scenario it should return same thing, DLL is empty. And then if DLL has one element, so in this scenario same thing will be same code will be applicable for delete last. Okay, and now we are going to, and here we can provide return. okay, and here also we can provide return. And now we are going to write logic if DLL has more than one element. Okay, DLL has more than one element. Okay, so in this scenario what should be our code if you are going to delete last node? Okay, so we'll see, firstly we'll see the approach. Okay, so we have seen the approach to delete the first delete element at first position. Now we are going to see delete element at last position. Okay, so if doubly linked list has multiple element, that means the head is pointing to xx10 and tail is pointing to xx50. Okay, so both head and tails are pointing to different addresses. That means the doubly linked list has more than one element, more than one elements. Okay, so this is our node 1, node 2, node 3, node 4, node 5. So node 1 is pointing to, in next it's pointing to second node, and in prev it is pointing to null. Okay, that means there is no node before this. So we are going to delete element at last position. That means we are going to delete this node, okay, which is at last position. So our tail is pointing to xx50. That means that this is the last node. Okay, xx50. If you make our tail, okay, if you make address of tail equal to xx40, that means the our tail will point to last node of your W linked list. Okay, so in this scenario we can delete the last node of your W linked list. So we are going to see the approach. Okay, replace value of tail. So replace value of tail, which is xx50, replace value of tail, which is xx50, by previous address of tail. That means xx40. Okay, so this is the previous address of tail. So this is the tail. So what is previous address of tail is xx40. xx40 is our previous address of tail. So if you replace, this is xx40. So if you replace tail by xx40, then tail will point to your previous node. Okay, that means the last node will be deleted. So let's do, so we are going to delete xx50. Instead of xx50 it will be xx40, and then, so it is not pointing to xx50 now, it will point to xx40. Okay, so we have deleted this node. Okay, so now our tail is pointing to xx40, so we are ignoring this. So garbage collector will be garbage collector will delete this automatically. Okay, so now there is no last node inside our linked list. So this is our complete linked list after deleting the last node element from W linked list. So like this we can do in our coding also. We'll follow this approach and we'll complete the method. Okay, so if, what will be the last, so DLL has multiple elements. Okay, so what we'll do in this scenario, so tail, okay, tail dot prev. Okay, that means the tail is pointing to last element, and we are what we are doing, tail dot prev. Okay, and dot next. Okay, so the tail is pointing to last element. If you do tail dot prev, then that means the, it will be the previous node. So we are going, so this will be for your previous node. So now we are on previous node, and in previous node we have next. Okay, which will point the address of your next node. So if tail dot prev dot next will do, then next if you do null, so that means it will not point to any new node. That means in next node it will not point to next node. So I will show you what I did. So this is our tail. Okay, so I did tail, which is xx50 dot prev. So xx50 dot prev. What is xx50 dot prev? Xx40. This is xx40. So tail dot prev, which is xx40, and then dot next, which is xx30. Here we are doing equal to null. We are doing okay. So here, yeah, tail dot prev dot next is equal to null. We are doing okay. And then next, what we are doing here? So we are making changing the address of tail. Okay, we are changing the value of tail. So what should be inside tail? So tail equal to tail dot previous. Okay, so now our code is done for this. Okay, so now tail will not point to your last element, it will point to your second last element. So yeah, it's done. Now we can run and check is it working good or not. So let's run quickly. So now we have, firstly let's run and check what we are getting now. Let's comment this dll and this. Okay, then let's run dll print forward. Yeah, we have 20, 10 and 30. 20, 10 and 30 in our Doubly link. So we are going to delete first. Okay, so dll dot delete first. So what should be our output after deleting first? Dll dot print forward. Okay, print forward. So after deleting first, our output should be 10 and 30. Okay, so let's print. Are we getting 10 or 30 or not? Yeah, we are getting print forward and dll is empty. So when you are performing this, okay, that means the delete dot delete first and delete dot print forward. Okay, so we are deleting first element. Okay, so in our double linked list we have 20, 10 and 30. Okay, that means the three elements. But when you are deleting first, so if you are doing print forward, then you are getting delay is empty. But this is not correct output. Our output should be, if you are deleting first, then our output should be 10 and 30. But here we are getting DLL is empty. Okay, because there is no element inside our DLL. So something we are doing something wrong. So let's check. Let's verify once. It is deleting all the element when we are trying to delete first. So let's check why it's doing like this. So we'll check the methods. Delete first. Okay, so DLL is empty. If head equal to null, then DLL is empty. And now we are checking DLL has one element. So in which scenario DLL has one element if head dot next not equal to null. Okay, so it is right condition. But if you'll put a head dot next, if you'll put head equal to null. Okay, so if DLL has multiple element in this scenario, it will be also applicable. Okay, because head dot next will be not equal to null if DLL has multiple nodes. Okay, so on that scenario also, that means that this will be applicable for both the scenario. Okay, dll has one element or dll has more than one element, because head dot next will be null in both the cases. So here we are going to add some condition, which is dll has only one element. Okay, so in this scenario how can we check? So if head dot next, okay, equal to if we'll do tail dot next, head dot next, okay, or head equal to tail. Okay, if head equal to tail, if we'll do, that means head is also pointing to one same element and tail is also pointing to same element. That means dll has one element. Okay, so we have to do like this, head equal to tail. So let's do, and then it is easy to check the condition if dll has only one element, and then we can do head is equal to null and tail equal to null. Okay, that means here is until both are not pointing to anything. And same thing we can, same code we can do for this. Okay, if DLL has one element, so how can we verify if DLL has one element? So head equal to 10. Okay, and now let's run and check, are we able to get correct output or not. Yeah, now we are getting 10 and 30. So 20, 10 and 30 was our elements in DLL. Okay, and we are, what we are doing, we are removing first element, which is DLL dot delete first. Okay, so we are deleting first element. So after deleting first element, what should be available inside? It should be available 10 and 30. Okay, so we are getting 10 and 30 output after deleting first element. So we are getting correct output. Okay, so our problem was in this. Okay, because, okay, so now we have changed the condition to check only one element. Okay, so now this is done. So now we are going to check dll dot delete last element, dll dot delete last element, and then we will print dll dot print forward. Okay, so now we have two element. Okay, 10 and 30. If you remove the last element, then our output should be 10 only. Okay, so let's remove last, which is 30 should be removed, and output should be 10 only. So let's run again. Okay, so now we are able to remove first element and our output is getting 10. That means we are getting the right output. So we are able to delete last element. So like this we can perform all the operation with the help of Java. Okay, in Doubly linked list. So we have written all the methods, all the necessary methods. Okay, we cover add first, add last, print forward. Okay, print backward, back traversal and forward traversal, and we calculated the size also. We did the delete first. Okay, and we written the method for delete last. Okay, so we have covered all these method. Okay, so all these things you can do inside your linked list collection. Okay, linked list collection. So this is a linked list collection. Okay, so like this we can create one linked list inside collection class. Okay, this is the linked list. Okay, this is a class linked list extend abstract sequential list and implements list dequeue clonable and serializable interface. Okay, so we can, you can also do same thing. So if you want to add first element, to how we can do inside this list dot add first, list dot add last, list dot add first. Okay, so like this you can perform all the operation inside linked list. So let's check once. Okay, so we have added uh, add first, add last, and add first. Okay, inside linked list. So let's run and check what are we getting. Is it same that we implemented in our code? Okay, 30, 10 and 20. Okay, so add first will be 10, and then add last, that means the 20 and then 10. And if you are adding at first, then 30. So add first we are adding 10. Okay, add last. Okay, that means the 20 should be at last, 10 and 20, and then add first. Okay, so 30, 10 and 20. So this should be our output. I'm getting 10, 30, 10 and 20. Okay, so like this. If you want to remove, okay, so list dot remove first method is there, so you can remove. Okay, so if you're removing first, then 30 should be removed and our output should be 10 and 20. Okay, so if we'll try to do by for each method, so it should print 10 and 20. So let's print and check. Yeah, we are getting 10 and 20. Okay, so we are getting the correct output, 10 and 20 now. And again we'll do remove last. Okay, so let me comment this and we'll try to remove last element. Okay, so now we have commented everything and we have added add first, add last, and add first. So our output should be 30, 10 and 20. Okay, so now we are going to remove last. So remove last, that means the 20 should be removed, and in our linked list 30 and 10 should be available. So it should print 30 and 10. So let's run and check, are we getting 30 or 10 or not. Removing last element, 30 and 10 should be visible. Yeah, so we are getting 30 or 10. Okay, so like this we can perform certain method, which is add first, add last. Okay, everything inside a linked list of collections API. So both the scenario we did with the help of the node also we did, and we did with the help of the collections framework, and we understood the basic things of a doubly linked list. Okay, uh, linked list what is circular linked list, then types of circular linked list, then internals of circular linked list, add element at first position in circular linked list, add element at last position in circular linked list, delete element at first position in circular linked list, delete element at last position in circular linked list, and display circular linked list in forward traversal. And then we'll do coding questions of linked list. Actually we are going to do coding questions parallelly, so we'll firstly understand the approach, how can we do, and then we'll do the coding. So we are going to, this tutorial is related to only for beginners, so we are going to cover only from basic, and then we'll cover to advanced. So if you are advanced person, then you can go to last of the video, that means middle of the video, and you can see all the coding related things, coding related approach. So now we are going to continue from basic. So let's get started. So firstly we'll try to understand what is circular linked list. So if you know, circular linked list is a type of linked list. Okay, in previous video we have seen singly linked list and doubly linked list, and this is a third type of linked list. uh, so a circle linked list is a type of linked list where the last node point back to the first node. Okay, so our last node will point back to the first node, creating a circular structure. Unlike a traditional linked list where the last node point to null, in the circular linked list you can traverse the list indefinitely. So we seen singly linked list. So in singly linked list, last node was pointing to null. Okay, but in circular linked list, last node will not point to null, so it will point to address of your first node. Okay, so this is difference between singly linked list and circular linked list. And this is circular structure. Okay, so the last node next pointer point to the first node. No null node. Okay, so all nodes contains value of your next node. Okay, so there is no any null reference. Okay, inside your node. Traversal, so you can start from any node and traverse the entire list by following the next pointer. Okay, that means you can start from middle also, and you can go from middle to all the nodes. Okay, you can search all the node. Types of circular linked list. Okay, so we can implement circular linked list with the help of singly linked list. Okay, so and we can implement the circular linked list with the help of doubly linked list. Okay, so these are the types of circular linked list: singly circular linked list and doubly circular linked list. So you know the singly linked list and doubly linked list. Okay, in singly linked list it point the address of next node. Okay, and in doubly linked list each node point to address of your next node and previous node. So now we are going to see internals of circular linked list, how circular linked list works. Okay, so if you want to store data, okay, in with the help of your linked list, okay, circular linked list, data structure, then how can we do? So firstly, it will create one node. Okay, inside that node we have data and we have address. So address point to your address of your next node. So now we are going to create multiple nodes. Okay, in multiple nodes we will store the multiple data. So see, this is the first node. So here data is 10. So we are storing data 10, and this is the address of your next node xx20, and this is the address of your first node, which is xx10. Xx10 is the address of your first node, and xx20 is the address of your next node. So this is the second node. So address of second node is xx20. So your first node is pointing to second node. See, first node is pointing to second node, and then this is third node, data is 30 and is pointing to xx40, that means the fourth node. So and this is xx30, and see, second node is pointing to xx30, and now this is fourth node, and fourth node, the address of fourth node is xx40, and third node is pointing to xx40. This is the head of, okay, so head, okay, head is also a type of node. So head, what is the role of head here? So inside head we keep track records of your first node. Okay, so we can track the circular linked list with the help of head. Okay, so it is same as singly linked list. Okay, so head points to your first node of your circular linked list. So this is first node, this is second node, this is third node, this is fourth node, and see, this fourth node is pointing to first node. So it's creating a circle from node 4 to node 1. So this is internals of circular linked list. How, like this circular linked list internally works. Okay, so hope you understood all the points. So now we are going to see add element at first position. So how can we add element at first position in circular linked list? So we have two conditions: if linked list is empty and if linked list is not empty. So firstly we'll see if linked list is empty, then how can we add? So if head equal to null, that means there is no element inside linked list, because head is not pointing to anything, your head is null. So linked list is also null. Okay, so how can we do? So we have to firstly create a node. Okay, this is our node, new node. Okay, so address of new node is xx50, and its content value 50. Okay, and its content null. Okay, so it's not pointing to any address. So now we are going to replace value of head by address of new node. So how can we make connection between both? Okay, this is head, which is null, and this is new node. Okay, so how can we do? So if you'll provide the address of, if you will, that means the tail, that means this is your first node. So we have to provide the address of first node inside head. Okay, so we have to do head equal to xx50. So it will point to, so by default our value head is null. So we are going to replace value of head by address of new node. Address of value is new, address of new node is xx50. So we are going to replace head equal to, so we have deleted null, and now we have replaced it by xx50, which is address of first node, and now head is pointing to your first node. So like this we can do. This is a first step, and after that we have to replace address of new node by address. Okay, so replace address of new node. So now this is a circular linked list. So at the last of your circular linked list, it should contain the address of your first node. Okay, so in this case this is the first node as well as second node. Okay, so it should contain the first node. Okay, so what will be the first node? So first node will be also this. Okay, last node will be also same node. So it should contain the address of your address of itself. Okay, in null, address of null, it should contain address of itself, which is xx50. We have to provide. So replace address of new node. So this is address of new node by address. So by address, that means the address of new node. Okay, new node only. So here it will be, so we are going to delete address of new node, and in the seed of null it should be xx10. Now it's a completed. So now we have added successfully our first node inside circular linked list. So like this we can add first element inside circular linked list. And now we are going to see when, if linked list is not empty, then how can we do? That means the head is pointing to something, and this is the linked list, okay, which we are going to take as an example. So we have node 1, node 2, node 3, node 4, and this is head is pointing to first node, and at last first node is pointing to second node is pointing to third node is pointing to fourth node. Inside fourth node xx10 is there, so xx10 fourth node is pointing to your first node, this xx10. So now we are going to understand how can we add element at first position. So this is our already existed linked list, so it should be, our new node should be here, okay, and it should link to your first node, and inside head it should be, what should be available, address of first node, okay, and last node it should have stored, instead of x16 it should have stored the address of your first node, okay. So we are going to follow three steps for this. So first we will create a node, so we'll create one node. So this is a node which address success 10, but default value is 50 we are taking here, okay, and default we are taking here null, it's not pointing to anything. So now how can we do? So replace address of new node by head value. So replace address of new node, so this is address of new node by head value, okay. So head, that means the head is pointing to first node, so we are going to replace this address of new node by first node, okay, and first node is stored inside your head. So null will be deleted, and there xx10 is available. Now xx10 is pointing to your first node, so first step is done. Now we're going to follow second step, which is replace value of head by address of new node. So replace value of head, so this is value of head which is xx10. So now what should, instead of head, what should be here, it should be address of new node, okay, so it should be xx50. So now we'll delete the address, sorry, head value which is xx10, and now it should be xx50 which is address of new node, and now it will so it is not pointing to previous node, okay, that means the node first. Now it will point to your new node, okay. So now this is the first node, and this will be the second node, okay, this is third, this is fourth, this is fifth, okay. So now head is pointing to your new node which is first node now. So this step is also done. So now we are going to this one, fourth step, which is replace address of last node by address of new node, okay. That means that we have to do here at last also, we have to, what we have to do, so it should point to the address of your first node. So now first node is xx50, so in the series of xx10 it should be xx50. So now xx10 will be deleted, and now xx50 will be available. And so now xx50, that means the node 4 is pointing to direct your first node, okay. So we are making here one circle. So xx50 is pointing to, sorry, xx40, that means node 4 is pointing to new node, okay. So here xx50 is inside node 4. So see, this is address of new node, so it's making a circle. So because of this structure we call it circular linked list. It's making one circle from new node to new node to new node to node 4, and node 4 to then new node. So it's making a complete circle. So because of this behavior we call circular linked list. So now we understood how can we add element at first position. So now we are going to do parallel coding, okay, so that it will be easy to understand, okay. So I have already created one class, okay. So I'm going to switch data structure, this window, circular linked list, okay. So I have already did some POC. I'm going to remove everything and we write from scratch. Yeah, so we have one circular linked list class. We are going to create circular linked list. So how can we do? Okay, so for that purpose, firstly we have to create one node, okay, node class. Okay, so that will contain data and address. So we are going to private class node. Okay, node will be one private class, and so it will contain int data. Okay, so we can make it private int and data, and then private string. No, so what should be the next type? Next, we will store the address of your reference of your next node. Okay, so it should be also a node type, because if you want to store the reference of node, so it should be also a node type, otherwise it's not possible, you will get the compile timer. You can't store a reference of your node inside a string. So for that purpose we have to take node only. So now we have data, now we have next. Okay, and now we are going to create constructor, so that if you create the node, so it should assign the value. So generate constructor and select all. So now we have created constructor, so let's arrange properly. Yeah, so we have created constructor. So constructor to create node. Okay, so at the time of creating node, so we will provide the only data. Okay, so that means the we are not providing any next value. So next we are providing, next will be null by default we are making. Okay, and so now we have complete one node class. So we'll arrange. Okay, now we have node class. Okay, so inside circular linked list we have node, and we are going to keep track of head. So private. Okay, what will be the head type? Head type will be also a node. Okay, so private node, node and head. Okay, why you are taking node as a head type? Because okay, head will store the reference of your first node. So node is, first node is also a type of node. Okay, so reference we are storing in, what we are storing inside head, we are storing reference of your first node inside head. So head should be also a node type. Okay, if you want to store a string, so in another string, string a is there, if you want to store inside a string b, so string b should be also a string type. So same here also, here we are storing the address reference of first node. So this head should be also a node type. So now we have declared node head, and now we are going to keep track record of size. So private int size. Now we have, okay, so we have created the required necessary all the parameters, all the variables. Okay, properties, which is head and then size and then node. Okay, so we have everything. So now we can create all the methods, okay, which is required. So first we are going to create one main method, which with the help of main method we will test this circular linked list. Okay, inside, so inside this circular linked list class we are going to create all the methods. Okay, firstly we are going to create one method which will allow to add your data at first position. So public void add first. Okay, so we have created one method, and it should take int data. Okay, integer. And so we have two condition. Okay, what will be the condition? If linked list is empty. Okay, and again what will be the another condition? If linked list at first position. Okay, so if linked list has, if linked list, circle linked list has one element. Okay, we can make three condition. And if linked list, or you can do cll, circular linked list, cll circular linked list, and cll has more than one element. Element, that means node. Okay, more than one element, that means node. So don't be confused between element and node. So I'm making everything clear here. Node. Okay, so now we have three conditions. We have to write code for all the three conditions. Okay, if you're adding at first position. So if CLL is empty, so how can you identify if CLL is empty? If head is equal to null, nothing is pointing to head, that means the this is empty. Okay, so in this scenario, okay, how can we do? So firstly we have to create one node. So node we can create under top. Okay, new node. Okay, so new node is equal to new node is equal to new node. So we are creating node with value 10. Okay, so now we have created. Okay, and that node will use in every scenario. If CL is empty, so here we are going to write. Okay, so we have created node, and same thing we are going to. If head equal to null, then in this scenario what should we do? So head should point to your new node, so that means that head equal to new node. So it's done. Okay, this is a one line of code for this condition, and it should return, it should not go ahead because we have added. Now if CLL has one element, not, so we have to do some one line code also. It should be two line code. Okay, because head is pointing to new node, but inside what should we have to do some changes, because the node inside the node, it should also point the same node, that means it should point the as itself. Okay, so we have to inside new node. Okay, so like we have new node dot next. Okay, equal to, we have to provide the address of new node, so it should be new node. So new node dot next will be, sorry, yeah, because this will be the only one first element. Okay, so new node dot next will be also new node. Okay, so this node is pointing to itself, and then head will be new node. So now we are returning, and we are keeping track of size also, so we can make it size plus plus here. Okay, so now it's done. And if CLL has one element, so how can we do? If CLL has one element, then how can we identify if CLL has one element? That means we have head. Okay, so head if head dot next. Okay, if head dot next equal to head. Okay, that means the head is pointing to your first node. If first node dot next is pointing to head, that means itself. Okay, that means the it has only one element. Okay, if head dot next, that means the first node dot next equal to first node, then only one element. So you can write this logic to check if CLL has only one element. So we have only one. So how can we write the logic if only one element? So firstly we write new node dot next equal to head. Okay, so it will point, now new node dot next will point to the first node. Okay, and what we can do, we can do head dot next. Okay, head dot next head dot next equal to new node. So if only one element, okay, if CL has only one element, then what we can do? So new node dot next equal to head. Okay, what we created, what we created a new node. So new node dot next we can do head, because head is pointing to your first node, and then we are going to change. Okay, so this logic we are writing head dot next equal to new node, that means the this will be the last element. Okay, so last element. So set address of first element. first element set address of first element to set address of first set address of last node to first to address of first node. Okay, so when we did new node dot next is equal to head, that means that this is the our new node, so this will become the first node. Okay, and already available node which is head, okay, will become the second node. Okay, that means the last element. So here we are providing the reference of first node. So head dot next we are doing the new node, so now new node will be your first node. So we are setting here head dot next is equal to new node, and at last we'll do head, will assign will assign value of first node inside head. So what will be the value of new node first node? What will be the value of first node? So new node is our first node now, so we are going to provide head is equal to new node. Okay, so like this we have done all the three steps. Okay, when uh, circular linked list has only one element, and then we can do size plus plus. Okay, because we are adding, and we can return. Okay, so it should return from here. And we have third condition, if CLL has more than one element. So in this scenario what we can do, so when we adding element at first position, so firstly we will add the head value at inside our new node. Okay, so firstly we'll do new node dot next equal to head. Okay, so this will be applicable for new node. Okay, so we have done, and now what we have to do, we have to find the last element. Okay, and then we can set the, so find element, that means the last node. So we have to find the last node, and then we can, so if we find the last node, so this is our last node. Okay, so we have already added element at first position. So if we find this is the last node, then we can assign the address of new node inside node 4. Okay, so firstly we have to find out the node 4, that means last node, and then we can do node 4 dot next, okay, equal to head. So same thing we are going to, firstly we'll find and then we'll do the code. So for finding the last node, we are going to write some logic. Okay, so node current node, so now current node is pointing to head. Okay, so we'll do current node equal to current node dot next one by one. Okay, so it should be while, so how can you find last node? So if you'll do current node dot next, okay, equal to null, sorry, equal to head. Okay, so if current node dot next equal to head, that means we are at last position. Okay, so here we are going to, our loop should work till not equal to head. Okay, so we will be at second last. Okay, and then we can do next, then we will get the last node. So this should execute till current node dot next not equal to head. Okay, so now we can do current node dot next, current node equal to current node dot next, and like this we can find the our last node. Okay, node equal to, we have assigned the head value inside the current node, and we are checking the loop. If current node dot next not equal to head, so it should be current node equal to current node dot next. So like this we can find the last node. So this will be our last node. So now we can set address of first node, that means the address, that means the reference. Okay, address of first node, address of first node inside last element. Okay, so now we have last node which is current node. So current node dot next equal to, we are going to first node. So where is first available? So inside here, inside here we have address of first node. And now we can do, we can head equal to, head will point to new node. So current node dot next, so this is the last node dot next equal to, so head. So now current node dot next equal to head. So last node is pointing to head, but our head is pointing to, I think previous, it's not pointing to new node, it's pointing to first node. Okay, so now our new node will be, now new node will be our first node. So here in the seat of head we have to provide new node. Okay, so now current node dot next will be new node. Okay, so last node dot next will be new node, and then we can assign new node inside head. Okay, so our code is completed for adding the first element, and now we can do size plus plus. Yeah, so it's done. So we have written logic to add linked list at first position, link to add node at first position. So it's done. So now we are going to write logic to add at last position. So public void add last. Okay, so we will write, and for that purpose we are going to understand, so how can we write logic to add at last position. So add element at last position, we are going to see if linked list is not empty, then how can we write logic? If linked list is not empty, that means head is pointing to any node. Okay, so it's pointing to xx10. So xx10 is pointing to xx20, xx20 is pointing to xx30, xx30 is pointing to xx40. So we have four node, and xx40, okay, which is fourth node, is pointing to first node which is node 1. Okay, xx10. So this is our circular linked list. Okay, we have fourth node inside circular linked list, and head is pointing to your first node. So now we are going to add at last position. So our linked list should be added here. Okay, and what you are seeing inside fourth node, it should be, that means that we are seeing in node 4 what is available. So in the seat of next we have address of first node. So if you will add the fifth node, so in fifth node also it should point the address of first node, okay, which is xx10. And yeah, then I think then everything will be fine in, and head will also point to xx10. So we are going to create one node, and this is the node with address xx10 and value 50, and it's not pointing to anything, no, it's pointing to null only. And then find next, find last node of the element of linked list. So for that purpose we have to find out the last element of the linked list. So this is the last node. Okay, this is will be the last node, and after finding the last node we can do some changes here. What we can do, so here we have to provide the, instead of x10 it should point to the new node. Okay, instead of x10 it should point to new node which is xx50, and instead of null it should point to first node, that means xx10. So firstly we are going to replace address of last node, address of this is last node, by address of new node, by address of new node, that means xx50. So now xx10 will be xx50, so xx10 is deleted, and now xx50 is there, so xx50 is pointing to, now our fourth node is pointing to new node. Okay, so it's done. And then we'll do second steps, which is replace address of new node by head. So this is the new node address, this is the null we are getting it by default. So we what we'll do, so we'll delete this, and we'll inside this at the time of at the place of null we'll provide the address of first node, which is xx10. Okay, xx10, and xx10 is available inside head. So now we're going to delete null, and it will xx10, and it's done now. So now this new node will point to xx10, that means first node, so making a one circle. Okay, so like this we can add element at last position. Okay, so firstly we'll do the coding, and then we'll try to see how can we delete. Okay, so we are going to add, so going to write logic to delete from last position. So we are going to follow, so we'll check if cll, okay, is empty. Okay, if it is empty and you want to add, then how can we add at last position? And if cll is not empty, okay, so we are going to check two condition in this scenario. Okay, at the time of adding last, so if cll is empty, that means there's no any element. Okay, so it should be first also, it should be last also, so it should treat as same. Okay, like at first. So we are going to copy same code. Okay, if cll is empty from top, and we'll paste here. So this is done. So now we have to follow this if cll is not empty. So new node. Okay, we have to create the new node. So this code will also copy. So in industry of 10 we can provide data here. Okay, so it will not add hard coded data. Okay, so we can copy this node value, node creation code, and we can paste here. Okay, so it's done. If cll is empty, if cll is not empty, then we can write our logic here. Okay, so how can we do if cll is not empty? So firstly we have to, we can do new node dot next. What we can provide new node dot next, we can, new node will be our last node, so we can last node dot next, we can provide the address of first node. So where is the address of first node is available inside head, so we can do. So this is completed. Now we have to change the address of your last node. Okay, and last its address of last node, that means the address of your last node should point to your new node. So for that purpose we have to find the last node, and then we can change. So find the last node or last element. Okay, so find the last element. Okay, and then we can change the address. Okay, so for that purpose we have written, how can we find the last node? So for that purpose we have written logic. So like this we can find, so copy that logic from top and paste here. So now we have last node. Now our current node is our last node. So this is, so we want to change address of reference next, we want to change next of last node to new node. Okay, so now current node dot next will be your new node. So current node dot next will be new node, and that, and then we can do size plus plus. Okay, because we have added one element at last position. So like this we can do. So we have done. Now if CLS is not empty, so we have this is the first step. Okay, we have changed the next address, okay, of new node, and we have done the head, and then we have finded the last node, and we have changed the next of last node, which is new node. Okay, so this is done. So now like this we can add element at last position. So we have done. So now we are going to print. Okay, how can we display? For that purpose, I'm going to write one method which is public void print. Okay, so we are going to print by forward transversal. Okay, so how can we print if linked list is empty? Then how can we print? Okay, it should return. That means the linked list is empty. Okay, if linked list is empty, and then if linked list is not empty, if linked list is not empty. Okay, so if link is empty, that means head is pointing to null, head equal to null, then it should, what should it should return? Sysout system dot out dot print ln. Okay, that means cln is empty. Okay, empty empty, and it should return. Normally simply it should return. Now done. If linked list is not empty, then how can we do? So firstly we have to find element one by one. We have to take the element and we can print. So we have written logic to find last element, so it will go from first to last only. So here we can, with that of this logic, we can find. So this is the current node, this is the first node, and with that of this we'll get the first node, and then we are getting the one by one last till last node. So it will go first, then second, then third, then fourth, like this. So we can simply print here. Okay, so inside we can print. So like this we can print the element. Okay, so end node dot data. Okay, so first time it will print the data which is available inside first node. Okay, because this is pointing to head, current node is pointing to head, and then it will do current node is equal to current node dot next. Okay, so like this, and at last, so we can print the value till second last element, and at last we have to print the value which is inside last element. Okay, so like for that purpose, current node dot last, we have to print element last element. So like this we can print last element. So this is done. So now we can check how can we. So now we have done everything. So let's create one quickly class, and we can do cll equal to, we can add and we can display. Cll is equal to new circular linked list. Okay, and we are going to add cll dot add. First we are going to add 10, and then cll dot add last. Okay, sorry, cll dot add, you can add at first position 20, and then cll dot print. Okay, so let's print and check are we able to get correct output or not. So run it. So we have added 10, and then we have added 20, so our output should be 20 and then 10. So 10 add last, here should be data. Okay, int data we have to provide here. Okay, it's a, yeah, so we are getting 20, and then we are getting 10. Okay, so that means that it's right, we are getting correct one. And then we are going to add cll dot add last. Okay, so what should be the output? Now output should be 20, 10 and 30. So let's run again and check. 20, 10 and 30, yeah, that means that we are getting the correct output. So add again at last position, cll dot add last at 40. Okay, and let's check again. Yeah, we are getting 20, 10, 30 and 40. We are able to add correctly at first position, at last position, so it's working perfect. So hope you understood till now. Then we'll going to write code to delete from first, and how can you delete from last. So now let's follow PPT again, and we'll do. Now we are going to delete element. Okay, so firstly we are going to see if linked list has only one element, then how can we delete. So we are going to delete from first position. Okay, so this is our data. That means the linked list has only one element, then how can we delete. So this is element which is available inside linked list. Okay, so this is pointing to head. Okay, so now we can say linked list has SQL linked list has only one element. Okay, head is pointing to xx50 and xx50 is pointing to itself. Okay, so how can we delete. So replace value of head by null. Okay, if you will do head equal to null here, so automatically it will be deleted. That means the head will not point to any node. So this is so simple to delete if there is only one element. Okay, so let's delete. So now xx50 will be deleted, and instead of xx50 null will be available, and so now head is not pointing to anything. So now node is deleted, which is inside CLL, circular linked list. So like this we can delete the element, and now we will delete element at first position if linked list has multiple elements. Okay, so linked list is not empty. So how can we delete. So if linked list has multiple elements, so how can we? So this is the head. That means the head is pointing to x extent. That means that there are multiple elements. Okay, inside there is element inside CLL. Okay, so head is pointing to x extent, and x extent is pointing to xx20, xx20 is pointing to xx30, xx30 is pointing to xx40, xx40 is pointing to xx10. Okay, so this is a one complete CLL, circular linked list. So now we are going to delete element at first position. So this is our first position. So it should be deleted, and in this is of this head should point xx20. Now head is pointing to xx10, so head should point xx20, and this should be deleted. And instead of this, in node 4 we are getting xx10, which is address of your first node. So instead of xx10, it should be xx20. Okay, because this first node will not be available. Okay, after deletion of this node. So we are going to do two steps. So firstly we are going to replace value of head value of head. This is value of head by next address of head, by next address of head. That means value of head by next address of head, which is xx20. Head dot next will be xx20, which is address of your next two node 2. So if you replace this xx10 with xx20, then this node will be ignored. So we are going to do. So now xx10 is deleted, and now we have set xx20, and then this is not pointing to node 1. Now this will point to node 2. Okay, so like this first node will be deleted. Now first node is deleted. Okay, so it should not be here. Okay, so it should be, it is deleted now. Okay, so it is deleted, nothing is there, it should not be available here. Okay, so we have deleted. let's it, let's Okay, so now we have deleted. Now what we can do, so we are going to see second step. Okay, so what is second step? Replace address of last node by head. Okay, so we have deleted the xx10. So now xx10, instead of xx10, what should be available? It should available the first node. So now what is first node? So now this will be the first node. xx20 will be our first node. So instead of xx10, it should be xx20. xx20. So now let's delete xx10. So this is our last node, and then we are deleting xx10. Now xx20 is the head value, that means the first node, and then it will point to the your first node. Now node 4 will point to the first node. So there is no any node 1. We have deleted everything from. Okay, so head is also pointing to node 2, and last node is also pointing to node 2. So this is one complete CLL, circular linked list. Okay, we have deleted deleted from first position. So it's done. So now how can we delete at last position? So we are going to delete from last position. So how can we do? So if linked list has multiple element, okay, if linked list has multiple element, then how can we delete from last position? So head is pointing to x extent. That means the linked list has multiple elements. Linked list has elements. Okay, some elements are available inside linked list. So x extent is pointing to x20, 20 is pointing to x30, x30 is pointing to x40, x40 is pointing to x10. So we have four node, and head is pointing to first node, and node 4 is pointing to first node. Okay, so it's making a circle. This is a CLL. Now we are going to delete at last position. So this should not be available. Node 4 should not be available. So how can we do? Instead of xx40, sorry, instead of xx40, okay, which is available in node 3, if you'll make it xx10, okay, if node 3 will point to x node 1, then node 4 will be ignored. Okay, so it will not be available. So how can we do? So we can find the second last node, which is node 3, okay, and then we can do node 3 dot second last node dot next equal to first. First, that means the head value you can assign. Second node dot next, second last node dot next equal to head. If you do, then this fourth node will be ignored from our CLL. So like this we can delete element from last position at last position. So let's follow the steps. So traverse to the second last element. That means that we have to come to the second last element. So this is the node 3 second last element. So we can, so this is our second last element, and then we have to set replace address of second last element by head. So like replace address of second last element, which is this one. This is address xx40 by head. So head is x extend. Head is pointing to first element. So now xx40 should be x extend. So now let's delete xx40 deleted. X extend is here, and now this is not pointing. So now everything is deleted because node 3 is not pointing to node 4. So there is no there is no any difference between node 3 and node 4. So it's making a complete circle from node 3 to node 1. Inside node 3 there is xx30 xx10, which is address of your node first. Now it's done. So like this we can delete element at last position. Okay, so now we'll do the coding for both the thing, which is, let's just continue the coding. Okay, so firstly we are going to write one simple code to get size. Okay, so public get int get size. Okay, and it will return size. Okay, so we will also try to print the size. Okay, how, what is the print size? Okay, system, because we are also keeping track record of size. Okay, print ln and size, size size. How can we get size? So cll dot get size. So let's run. So you are getting size 4. So we are getting the correct size. Okay, so now we are going to write logic to delete element from at first position. So public void delete first. Okay, and so this is the method. So we have two condition, three condition. We are going to check if linked list is empty. Okay, if linked list has only one element. Okay, and if linked list has more than one element. Okay, linked list has more than one element. You can make it CLL. Okay, CLL. Okay, and so CLL is empty. So how can we do? if if head if head is pointing to null, that means CLL is empty. If head equal to null, that means we will print one message, simple message, sysout dot system dot out dot print ln. That means CLL is empty. Okay, so we can't delete it. So and return ret return. Okay, so here is, there is nothing inside CLL. So print one normal message CLL is empty and then return from here. Okay, and then if CLL has only one element, so how can we do? How can we check CLL has only one element? So we will copy from top. We have already written. How can we check? Yeah, head dot next equal to head. Okay, so if head is the same node is pointing to itself, so that means the only one element. So we have copied the code from top, and now we will write. How can we delete if only one element? So normally we'll do head equal to null. Okay, so now head is not pointing to anything. You can do, and we can do size minus minus. So we have deleted, so we can do size minus minus, and we can simply return from here. Okay, so we have written the logic for this also. And now we have third condition, which is if serial has more than one element. So how can we do? Okay, so for that purpose we have to go the last element. Okay, so we have to go till last element. So we have to firstly last find last element. Okay, find last, we have to find the second last element, because we are going to change the next address of second last element to the your first. Okay, so find second last element. Okay, so how can we? So we have written the code to find the last element, so we'll modify some modified code here. Same code will modify the to find the second last element. So see, so previously we were keeping track record of current node and only current node. So we are going to make, we'll keep track of current node and second node. Okay, so current node will become last node. Okay, so this will be the last node, and then this will be the second last node. Okay, so SEC, okay, simply is sec last node. Okay, so last node we can get. Actually we are deleting. So this method is to delete first node. Okay, so we no need to write this all code. Okay, this code will applicable to write to delete the last node. Okay, so we are deleting the first node. So let's remove from here and write the logic to remove the first node. So we are removing the first node. Okay, so first node, that means the, so head will point the first, head will point the address of first node. So we can do, if inside head, if you provide the address like head equal to head dot next, then it will not point the first node, it will point the second node. Okay, so like this we have to do. So that will be the second step. And first step, what we have to do, so let's change the address of your last node to second last element, sorry, second element, because we are going to delete the first element. You are going to delete the first element. So now last node will point the so now your last node will point the second element. Okay, because first node will be deleted, and now second will be your first node. So last node will point the second node. So firstly find the last node, and then we'll change the address of that node. So find last node. So we'll take the same code to find the last node. Okay, so we have finded the last node, and then we'll do some modification. What we'll do, so at last node we have last node dot next. What we'll do, head dot next, last node dot next equal to head dot next. That means we are changing the last node, next of last node equal to head dot next. That means head is pointing to first node. So if we'll do first node dot next, that means the we'll get the value of second node. So like this we can change the address of your last node. And then inside head, what we have to do, so head should point to your second node. So you can do head dot next. So now head will point to second node. So this is the two lines of code, but before that we have to find the last node. Okay, so we did the this head dot next equal to head. Okay, so this one we did in second steps, because our head value will be correct. Okay, so firstly we did this because we'll get the correct head value, and then we did the head equal to head dot next. Okay, so it's done now. So let's do size minus minus, because we are deleting it, size minus minus. Okay, and then it's done now. We have written the code to delete the element from first position. Okay, so let's write the code to delete from last position. So public delete last, public delete last, and make it wide. So we are going to delete from last position. So we are going to write same three condition. Okay, if linked list CLL is empty. Okay, if CLL has only one element. Okay, only one element, and if CLL has more than one element. Okay, so three conditions. So if CLL is empty, then how can we delete? So same, we'll copy from top. If CLL is empty, so we'll copy from top. This is done. And then if CLL has only one element, that means the so so we can also copy the code from top. For this code will be same, because only one element is available inside your CLL. Okay, now we are going to write logic. If CLL has more than one element, so how can we delete from last? Okay, so for that purpose we are going to write our logic. So how can we do? So firstly we are going to delete from last. Okay, so last node contain the address of your first node. Okay, so if you delete the last node, so our address of first node should be available inside your second last node. So firstly, for that purpose we have to sorry, so for that purpose we have to find the second last node. Okay, and then we can do second last node dot next equal to head, because head will point, head is pointing to address of your first node. So firstly find the, then find the second last node. So we have logic to find last node, so we'll modify this code to find the second last node. So write here this logic, and now current node we will make the second last node. Okay, now head will point to the second last node, and now node last node. Okay, last node equal to head dot next. So we can make it current node. Okay, so current node. So this is our second last node, and second node will be the last node. So this will be the last node. So don't be confused. So second last second last node will contain head value, and the current node, that means the last node, will contain the head dot next. Okay, next to that. Okay, and then we are checking if current node dot next not equal to head. Okay, so previously let's remove this one. Previously we were storing current node equal to current node dot next. Okay, so now we'll store the second last value also. So second value, what will be second last value? Second last value is equal to second last value dot next. Okay, so we are keeping track of both the, so now we have second last or last. Okay, both. So like this we can get the second last node. Okay, so here we can set address of last element to head. Okay, so set address of second last element to head. Okay, so we are going to set, so now we have second last node. So second last node dot next equal to head. So address of your first node. So now we have did, and now we can delete size minus minus. We can do, we have deleted. So like this we can write logic to delete the element at which is at last position, delete last. So it's done. So let's check, are we able to delete correctly or not. So previously we were getting 10, 20, 10, 30, and 40. So let's delete. So cll dot delete first. So it should get 10, 30, and 40. 10, 30, and 40, because we are deleting 20. Delete sorry, delete firstly, delete first. Okay, so we should delete 20, and output should be 10, 30, 40. So let's run and check. 10, 30, and 40. So we are getting, let's print cll dot print after deleting. Okay, and let's remove this, and again let's run again. Actually it's not printing. Actually we did some copy paste. Okay, so it's printing the, actually it did the copy paste, so it's printing the deleted element. So let's comment and then check. Okay, our code is correct. So let's delete this out, and let's print again. Okay, so we are getting 10, 30, 40. So let's comment and then check. Let's comment this cll dot delete first and then check. See, we are getting 20, 10, 30, 40. So 20, 10, 30, 40. So if you do delete first, so our output should be 10, 30, 40. Okay, so let's run again. 10, 30, 40, we'll see. So we are getting 10, 30, 40. That means we are getting the correct outputs. And then again let's delete delete last. Okay, delete last, and then check again. So now output should be 10 and 30 because 40 should be deleted. 1030 should be output. Let's run. Yeah, we are getting the 1030. That means we are getting the correct output. So we are able to. So let's print the size. Okay, after deleting. Okay, so it should print 2. Okay, serial dot get size. Let's print. Yeah, we are getting size 2. So let's add something. CLL dot add first. Okay, and add 40 at first position. Okay, so now output should be about 10 30 40. So let's run and check. 40 10 and 30 should be output. 40 10 and 30 we are getting 40 10 and 30, and we're getting size also. So we are getting the correct output. We are able to add at first, add at last, add delete at from first, and delete from last. So like this we can perform all the methods, okay, with the help of circular linked list. I hope you understood all the points from initial to last. If there is any doubt, so please let me know in comment section. Anyone, if anyone is interested, can participate, okay, in comment section, and so we can learn together. Hope you understood all the point which I covered in this entire video. So if you are loving my efforts, please like, share and subscribe. Bye everyone.